Regarding number 9, we're given f of x is equal to the integral from 2 to 3x of the natural log of 1 plus t squared dt. We are charged with finding f prime of 1 and f double prime of 1. Before we can find f prime of 1, we need f prime of x. F prime of x is easy to find. We're going to do the same thing we did up in the top half of the paper. We replace the t with our inner function. So we have 1 plus, and then in parentheses, 3x being squared. Again, since our upper bound is an inner function, something more than x, we have to multiply by its derivative, and the derivative of 3x is 3. We're interested in the derivative's value at 1. We want f prime of 1, so we have the natural log of 1 plus 3 times 1 is 3, 3 squared, times 3. 1 plus 3 squared, well 3 squared is 9, plus 1 is 10, so we have the natural log of 10 times 3, or 3 ln 10. Now we need f double prime of x, which means we have to derive the first derivative, which is right here. Let's rewrite this slightly just to help us out here. 3 can go out front, so we have 3 natural log, and then we have 1 plus 3 squared is 9, x squared is x squared, so we have 9x squared. So there's our first derivative in an easier manner to be derived. We have 3 times the natural log of ugly. 3 is a coefficient, so it stays, or rather it moves into our second derivative. We then have the natural log of an inner function. We have the natural log of ugly. Our rule says that it's a fraction. The original goes in the denominator, and the derivative of this goes in the numerator. The derivative of 1 is 0. The derivative of 9x squared is 18x. So we have 3 times 18x over 1 plus 9x squared. Again, we need to find f double prime of 1. So we have 3, 18 times 1 is 18, 1 squared is 1, times 9 is 9, plus 1 is 10. So we have 3 times 18 over 10, and that's the same thing as 3 times 9 over 5. So we're looking at 27/5 as a simplified answer. In regards to number 10, these are true-false questions. We need to know if any of the options below is an antiderivative for g of x is equal to the sine of 2 plus x squared. Well, let's look at A. If we were to derive this, will we get sine of 2 plus x squared? If so, then this would be an antiderivative for g. If not, then we'd have false. So let's derive this. Sine of t, we're going to put in 2 plus x squared. Alright, so if we were to derive this, let's put the derivative symbol out front. That would be equal to, we replace t with 2 plus x squared, so we have sine 2 plus x squared. But then again, we have something up here, which is more than just x. We need to multiply by the derivative of this upper bound. The derivative of 2 plus x squared is 2x. So we need to multiply by 2x, which does not equal g. So this is false. For part B, same thing. We're going to put x squared in for t. So this is equal to the sine of 2 plus x squared. But again, our inner function, again, I forgot my derivative, sorry. There we go. We're going to derive this. Our inner function is x squared, so we need to multiply by the derivative of x squared, which once again gives us the same answer as before. It's not g. So this is false. Finally, we have to take the derivative of this option. We're going to put x in for t. When we do so, we have the sine of 2 plus, and then this t is replaced by that x. So x squared. There is no more in our upper bound other than x. So there's no need to multiply by the derivative of the inner function, or multiply by the derivative of ugly, which means we're done. And lo and behold, this is equal to g. So 10C is true.